Hello class, and welcome to the first lesson in Unit 4. In Unit 4, we are going to explore the periodic table. By the end of this lesson, you should be able to identify the names and characteristics of the key groups on the periodic table, classify elements according to their locations on the periodic table and their physical properties. We did a little bit of that in Unit 1 when we looked at metals, nonmetals, and metalloids. We'll expand on those ideas in this unit. Explain how the periodic table was developed and organized, and identify similarities and differences between periods and groups on the periodic table. Make sure you have your Regents Chemistry reference table for every lesson in this unit, as this is the main focus of all of our learning this unit. The Russian chemist Dmitry Mendeleev was credited for developing the ideas that put forth the periodic table. He arranged the elements in order of increasing atomic mass, and he placed them in groups so that they periodically revisited a regular pattern of chemical reactions. Our current periodic table was developed by Robert Mosley. Mosley organized the elements in order of increasing atomic number. There are a few cases on the periodic table where the atomic number increases, but the atomic mass does not. Periodic law is a rule that we observe. Similar properties recur periodically when elements are arranged according to increasing atomic number. The beauty of Mosley's periodic table, combined with the work that Mendeleev began, was we were able to predict which elements were missing. Not only were we able to predict missing elements, but we were even able to describe the properties they should have based on the periodic law. Can you explain how the periodic table was developed and is currently organized? Remember, just look at your reference table. You can see that it's definitely organized by order of increasing atomic number. On the periodic table, we have two major groups. We have periods, which are called horizontal rows. Every period has the same number of principal energy levels, also known as electron shells. And groups are vertical columns. Elements that are in the same groups tend to have the same valence electrons, resulting in very similar chemical properties. So here you can see our periodic table, and you can see that the periods are horizontal, and there are 7 periods, and the groups are vertical, and there are 18 groups. So when we examine the periods, what we can see is that the atomic number increases as we move from left to right. The nuclear charge also increases because the nuclear charge is always the atomic number. The number of principal energy levels in a period in a horizontal row is constant. Remember, principal energy levels are electron rings. The number of valence electrons changes as we go across the period. And the stable ion structure, meaning the number of electrons gained or lost to become a more stable noble gas valence electron configuration, also varies. Now, the vertical columns are called groups. In each vertical column, you can see that the atomic number increases, and the potential and the principal energy levels increase by 1. So as we go down the group, you'll notice that we continually add 1 shell of electrons, but the number of valence electrons is the same. That means that since the number of valence electrons are the same, the stable ion structure will also be the same, giving elements in the same vertical column called group similar chemical properties. one interesting thing about our periodic table is there's actually a section cut out. So this lower section is actually part of period 6 and period 7, and it should be pasted in. But to save paper, as we only have one Earth, we cut it out and place it below because it has a unique electron structure anyway. So you can see this is what the periodic table should look like if we pasted in those lower elements called the lanthanides and actinides into our periodic table. But this makes for quite a wide table, so it's, again, easier just to kind of cut it out and place it in its own separate section. So what you'll notice is that the valence structure is fairly constant for most of the elements that are in the same group. So the leftmost group, called group number 1, all of these elements have a valence of 1. And if we look at the rightmost group, called the noble gases, all of these elements have a valence of 8. Recall that 8 represents the most stable, lowest potential energy electron configuration. So most elements strive to gain or lose electrons so that they can have a valence of 8, just like the elements on the right of the periodic table, which we call noble gases. The reactivity of all elements is determined by the number of valence electrons. All atoms except hydrogen are stable when they have a valence of 8. So the reactivity of elements is determined by the number of valence electrons. All atoms are stable when they have a valence of 8 electrons, called a full valence shell. It's also called an octet. The closer to a stable octet, the more reactive an element will be. So if an element only needs to gain or lose 1 electron, you can expect it to be much more reactive than an element that needs to gain or lose 3 electrons to obtain a stable, low energy, noble gas valence electron configuration. Now, elements, hydrogen and helium in period number 1, only need to have 2 valence electrons to have a full valence shell, as they only have 1 principal energy level, the first principal energy level of electrons to fill. So 8 is great for almost all the elements, but 2 will do for period number 1. So between this list of 3 elements, which ones are going to be the most similar and why? Well, of course, it's going to be the ones that are in the same group, because the ones in the same group have the same valence electrons. Can you identify the similarities and differences between periods and groups on the periodic table? You don't need to memorize these. Just make sure you know how to look them up on your periodic table. Let's look at some specific groups and their characteristics that you'll have to know. Group number 1. Now remember that all the metals lie to the left of the staircase, so group number 1 are called the alkali metals. Group number 1 are the most reactive of all the metals because they only need to lose 1 electron, as we can see, because their oxidation state is a positive 1 in order to obtain a stable noble gas valence electron configuration. Like most metals, these are shiny or lustrous, malleable, which means they can be bent, ductile, means they can be pulled into wires, and good conductors of heat and electricity. These only have 1 valence electron. These are called alkali metals because when they're placed in water, they produce a base, the opposite of an acid. They produce a base, the opposite of an acid, which most of the world calls an alkali. They produce a base, the opposite of an acid, which most of the world calls an alkali. Sodium metal, you can see here, is an alkali metal. So it has a lustrous sheen, but it easily oxidizes. So the outside of it appears kind of dull and gray, but when it's cut, you'll be able to see the metal appearance. But it's highly reactive, so it's stored in a jar like this under oil, so it cannot react with water. Group number 2 are called the alkaline earth metals. You may have heard the term alkaline when describing batteries. So the batteries you buy in the drugstore don't have battery acid, they have battery base or alkaline solution. Now, like alkali metals, these metals also produce a basic solution in water, but they're a little bit less reactive because they need to lose 2 valence electrons in order to become stable noble gas valence electron configurations. Now, both the elements in group number 1 and group number 2 are so reactive that they're always going to be found bonded to other elements in nature. So you're not going to find them in their elemental state. You'll have to undergo a chemical reaction to break the bonds to isolate them as pure elements. Calcium is an example of a metal. Again, you can see from this calcium that it's very oxidized on the outside because it quickly reacts. Now, group number 17 are called halogens. Many of the stage lights that we use halogen gases because they are most stage lights use halogen gases because they burn very bright. Incidentally, most stage lights use halogen gases because they burn very bright. Incidentally, though, they also could burn very hot. Many halogens produce diatomic elements. Fluorine, chlorine, bromine, and iodine are all diatomic. That means in nature, they're never found as a single atom, but instead their elemental state is they're bonded as a pair to themselves. Most of the halogens have a -1 charge, but there's other charges possible. You don't need to memorize it though. It's on your periodic table. Halogens have 7 valence electrons, so they only need to gain 1 more electron to obtain stable noble gas valence electron configuration. That's why they're so reactive. The last group that you have to know about are called the noble gases. The last group we have to talk about are called the noble gases. Group 18 gases are colorless gases that are extremely unreactive. They are unreactive because they have a full valence shell. Now, groups 3 through 11 are called the transition metals. They are called transition metals because they have multiple oxidation numbers. They transition between 2 different ions with different oxidation numbers. One important fact that you need to know about transition metals is they form colored ions in solutions. So when a solution is colorful, it usually has an element from group 3 through 11. Like our blood is red because it has the element iron. Insect blood may be blue or green because it may have copper or manganese. So here you can see the transition metals. They're kind of located in the middle of the periodic table. As a review, remember that metals are on the left side of the staircase, and they are good conductors of heat and electricity, ductile, malleable, lustrous, usually solid with STP, and they tend to lose electrons, which means that they undergo a process called oxidation, an increase in oxidation state in order to obtain a stable noble gas valence electron configuration. While nonmetals are on the right side of the Volt staircase. They tend to be poor conductors of heat and electricity, brittle solids, though many are liquids and gases, dull. Many of these are gases, except, of course, bromine is a liquid at STP. They tend to gain electrons when bonding. Gaining electrons is a process called reduction because the oxidation number or the charge goes down. So by now you should be able to explain how the periodic table was developed and organized and identify similarities and differences between periods and groups. This marks the end of lesson number 26. Make sure you've taken good notes. Please write down any questions you have and bring them to class. I will answer them if you ask them. Complete your homework on Google Classroom and put your reference table, which you should be definitely using, and your calculator back in your backpack so you are prepared for class. I'll see you soon.